Hello everyone, I'm Mia.
And I'm Max, and we're going to talk to you about negative emission technologies.
Negative emission technology is the name for any technology that takes more CO2 out of the atmosphere than it puts in.
As I'm sure many of you are aware, carbon emissions have increased significantly since the 1900s. Since 1970, CO2 emissions have increased 90%, with emissions from humans contributing about 78% of the total increase. This has increased the global temperature, and if emissions continue to rise, the temperature will follow suit at an alarming pace, which has adverse effects on the global climate.
Because of the negative environmental impacts of climate change, people have worked on solutions, leading to negative emission technology, known as NETs. Now that we know the definition of NETs, let's dive into the main categories of this technology. There's afforestation/reforestation, which is planting new trees on previously unused land or replanting trees where deforestation has occurred. There's land management, which is a process that uses different techniques to better sequester CO2 in the soil. These include modern farming methods, grassland restoration, and creation of wetlands and ponds. Then, bioenergy with carbon capture and storage, known as BECCS, which consists of farming bioenergy crops which extract CO2 as they grow, then burning them for fuel and putting the resulting emissions underground.
Then there's enhanced weathering, which is spreading pulverized rocks onto soils and the ocean to speed up the natural weathering process that takes CO2 from the atmosphere. There's also direct capture of CO2, which means sucking CO2 out of the air and either burying it underground or using it in a chemical process to make something such as plastic. And finally, ocean fertilization, which means adding iron and nitrogen to the ocean to increase the rate at which microscopic plants photosynthesize. This chart briefly shows the cost and development stage of each of these technologies, as well as giving an overall assessment of feasibility. However, when looking at NETs, there are several large obstacles that make them difficult to pursue. The first being that there's no incentive for private companies to invest in this technology, because there are no obvious co-benefits other than mitigation. And beyond this, the technologies are very costly and need large scale to make any economic sense whatsoever. This means the only likely situation in which these technologies would be funded is from large government subsidies.
Another issue is that of opportunity cost. Investing in NETs takes funding that could otherwise be spent on reducing existing emissions, which many argue is more cost-effective and important. And then finally, the issue that plagues nearly all environmental initiatives is that of the tragedy of the commons, meaning that since carbon emissions and climate change affects the entire world and not just one country, there is diffused responsibility and consequence, disincentivizing any one country from attempting to develop these technologies for fear of other countries free-riding off of their efforts, as well as the possibility that their contribution may be insignificant.
However, despite these difficulties, the development of this technology is still important because certain industries, including agriculture and aviation, will always produce positive emissions, so negative emission technologies will be required in order to make these carbon neutral.